Hi, I am Dr. Ayda Başgül Martin, and in this video I will talk about the structure of an atom. If you would like to watch more videos like this, don't forget to click the like and subscribe buttons below. Before starting to talk about atom, I wanted to share with you a photo of the Atomium, one of the most beloved buildings in Brussels, Belgium. It is a 102-meter tall and 18-meter wide in diameter, iconic stainless steel clad spheres connected to each other with tubes. The visitors are allowed to walk and even dine in. It is designed to replicate a 165 billion times magnification of an iron crystal. At the end of this video, you will be presented to the definition of an atom, atomic number, atomic weight, isotope, and ion, informed about the subatomic particles, and together practice the properties of the carbon atom. Atom is the structural unit of the matter. An element is a substance that cannot be broken down into any other substance. Every element is made up of its own type of atom. They all has to be the same atom. All matters, solid, liquid, or gas, composed of atoms. The earliest atoms were primarily hydrogen and helium, and they are still the most abundant elements in the universe. An atom composed of three subatomic particles: protons, neutrons, and electrons. You may know that protons and neutrons made up smaller particles that called quarks, but I will refer only protons, neutrons, and electrons as particles that form the atom. Protons and neutrons found in the center, or in other words, nucleus of the atom. However, electrons located outside of the nucleus in an electron cloud that has a radius 10,000 times greater than the nucleus. The nucleus of an atom was discovered in 1911 by Ernest Rutherford, a physicist from New Zealand. In 1920, Rutherford proposed the name proton for the positively charged particles of the atom. He also had a theory there was a neutral particle within the nucleus, but only one of his students, James Chadwick, a British physicist, was able to confirm this in 1932. Now let's repeat the important point here. Protons and neutrons are residing in the nucleus at the center of the atom, while electrons exist in a cloud orbiting the nucleus, as shown in the diagram at the right upper corner of this page. Electrons are extremely lightweight, comparing to heavier proton and neutron in the nucleus. Protons and neutrons form more than 99.94% of an atom's mass. When atomic weight calculated, only protons and neutrons are taken into consideration, and electrons are not counted due to their little mass. Protons and neutrons located in the center, nucleus of an atom, and together they are called as nucleons. Only the most common variety of hydrogen has no neutrons. Instead, has one proton and one electron. The protons have a positive electric charge, whereas the electrons have a negative electric charge. The neutrons have no electric charge. They are neutral. As an easy remembering tip, think positive and proton start with letter P. The core of an atom, positive, while periphery, negative. The elements have equal number of protons and electrons, therefore they are electrically neutral. The electrons in an atom are attracted to the protons in the nucleus by the electromagnetic force. This force binds the electrons surrounding the smaller nucleus. An external source of energy is needed for the electron to escape. The closer an electron is to the nucleus, the greater the attractive force. In this diagram, I draw for you the properties of a sodium atom. As you see, sodium element has 11 electrons, 11 protons, and 11 neutrons. Protons and neutrons located in the center, whereas electrons reside around the nucleus. Electrons move on their own electron shells. The electron shell closest to the nucleus, called first electron shell or orbit, and can carry maximum 2 electrons. If an atom has more than 2 electrons, we have to draw second orbit to place some of the other electrons. Second and third electron shells can carry maximum 8 electrons, which called as octet rule. The outermost shell of an atom called as the valence shell. The electrons in the valence shell are named as valence electrons, and they are the highest energy electrons in an atom, and therefore the most reactive. If an atom needs to share, lose, or gain an electron, this has to be from the valence shell. Periodic table is a display of elements according to their atomic number. As we talked before, the rows of the table, called periods, generally have metals on the left and non-metals on the right side. The columns, called groups or families, and contain elements with similar chemical behaviors. Atoms always have an equal number of protons and electrons, and the number of protons and neutrons is usually the same. Adding a proton on an atom makes a new element, while adding a neutron makes an isotope, or heavier version of that atom. Radioactive isotope of iodine, iodine 131, has a half-life of 8 days and employed in medicine to monitor thyroid gland functioning, to treat the thyroid cancer, and locate the spreaded tumor. The number of neutrons relative to protons determines the stability of the nucleus, which certain isotopes undergoes radioactive decay. Every element has one or more isotopes that have unstable nuclei that subject to radioactive decay, causing the nucleus to emit particles or electromagnetic radiation to increase the stability. The most common forms of radioactive decay are the alpha, beta, and gamma decay or radiation. Atoms are electrically neutral if they have an equal number of protons and electrons. Atoms that have either a deficit or a surplus of electrons are called ions. Electrons that are farthest from the nucleus may be transferred to other nearby atoms or shared between atoms. If a neutral atom loses a negative charge electron, becomes positively charged ion or cation. And if a neutral atom gains an electron, then that atom becomes negatively charged and called an ion. Most common cations of extracellular fluid in our body are sodium, calcium, and magnesium, whereas most common anions are the chloride, which is the major contributor for osmotic pressure gradient. Can you draw properties of a carbon atom? Let's draw together. Carbon is the 6th element in the periodic table, therefore have 6 protons and 6 neutrons and 6 electrons. When we draw, we must locate 6 protons and 6 neutrons in the center of the atom. And to place electrons, first we need to draw an electron shell around the nucleus and locate maximum 2 electrons on it. To place 6 minus 2, we have 4 more electrons to place. We must draw second or valence electron to complete our drawing. If you liked this video, make sure to click like and subscribe button below or leave a comment to encourage me to make more videos like this. Thank you for stopping by.